Okay, college algebra last day. We're going to start on page 2 and 3. The paragraph at the beginning of page 1 on the 4-point type notes is useful for your first few problems on very basic problems. But I really wanted to get into the problems that are more difficult. Equations with E, log equations, those ones that have a little more meat to them. So we're going to start with number 1 on page 2. As a reminder, when you're solving for equations with E, you need to combine all your E's no matter what side they are. You use any rules of math to combine them all together into a single E so that you can take the ln of both sides. And then you need to make sure that when you have answers, you don't have the answer like the log of -3, because you cannot have negatives inside of logarithms. So you need to throw out any answers that have that. So let's start with e to the x squared equals 200. You ask yourself, are all of my logs already on the same side? Or all my e's? Like, well, I only see one e, so that's usually good news. So we ask ourselves, what do we do next? We take the ln of both sides. So I take the ln of e to the x squared equals the ln of 200. We know ln and e cancel each other, so now I have x squared equals the ln of 200. Now I'm really just solving for x. And I do that, take the square root. So we take the square root of x squared and the square root of the ln of 200. So that means x equals plus or minus square root of the ln of 200. Now, if your homework asks you for a decimal answer, go ahead and put that in a calculator or Google the square root of the ln of 200. That means x is approximately plus or minus 2.302. So that problem's not too bad. I would prefer your answer be this first one, but if it asks for decimal, do the second one. And that one's pretty easy because we only had one e to begin with. What happens if we don't just have one e? E to the 2x plus 1 times e to the -4x equals 3e. There are 3 e's there. So these are multiplying with the same base. We use our exponent rules. When you multiply with the same base, you add your exponents. So 2x plus 1 plus -4x. Now if we add our exponents, 2x plus -4x is -2x, and the plus 1 just stays, equals 3e. So now we still have 2 e's left. What do? We need to divide the e over to the other side. Remember, this is an e to the first power, so when we divide, we're going to subtract, so the 1 minus 1 will become 0. So we become e to the -2x equals 3. Now the equation looks like the one we had in the first problem, where e is by itself. Since e is by itself, all we have to do is take the ln of both sides. If we do that, we get the ln of e to the -2x equals the ln of 3, which means -2x equals the ln of 3. And then divide by -2. So x equals the negative ln of 3 over 2. And again, if you need to put this in the calculator for an exact answer, go ahead and do so. And you get -0.549. Now, those are the more traditional kind of equations. Number 3 is the less traditional type. E to the 2x minus 4e to the x equals -3. If you see a 2x power and an x power, or something twice as big for e compared to the other one, you need to get everything over because it's a factoring problem. Why? If we let u equal 2x, or not 2x, u equal e to the x, this is really e to the x squared. So this becomes u squared minus 4u plus 3. And then all of a sudden, this is just a quadratic you can factor. This is u minus 3 and u minus 1. That means either if once we factor, we set them equal to 0, so that means either u equals 3 or u equals 1. But remember, we didn't start the problem in u. U is really e to the x equals 3, and e to the x equals 1. Take the ln of both sides, so x is the ln of 3, or x is the ln of 1. Now, ln of 3 is fine. That's a positive number on the inside. So is 1, but any log of 1, remember, is 0. So they're going to expect you to put that answer as it's either the ln of 3 or x equals 0 if you get one of these. So just be aware of that. Now let's look at the basic log equations. To solve log equations, instead of taking the ln of both sides, you either let e raise both sides to a power, it's just the same as rewriting. So 7 ln of 28, so we combine all logs using the rules, just like we combine all the exponentials, convert to exponential form, and solve. So first, I need to get my log by itself, so we'll divide by 7. So the ln of x equals 4. And then if we convert this to exponential form, we'll get an answer. But really, in order to get rid of ln, I need e to that power. And if I take e to the power on one side, I need e to that power on the other side. So that the e and the ln will cancel on the left side. So now x is equal to e to the 4th power. And again, if they want decimals, you can put e to the 4th in the calculator. This is approximately 54.598. I would always prefer this answer, but just make sure what they ask for. So if your base isn't e, then whatever your base is what you raise to the power. So here it's a log base 2 of x cubed minus 19. To get rid of log base 2, I need to take 2 and raise it to a power, and anything I do to the left, I also have to do to the right. So we have 2 to the log base 2 of x cubed minus 19 equals 2 cubed. Now the 2 and log base 2 will cancel, so all we'll have is x cubed minus 19. 2 cubed is 8, because it's 2 times 2 times 2. And now to solve this, I'm just going to move the 19 over. X cubed equals 27. And then we take the cube root of both sides. The cube root on each side gets us x equals 3. A nice, easy answer. Now those are the more basic situations you can encounter. The more complicated one is when it has a lot of logarithms. If there are a lot of logarithms, then you need to use the rules to combine all of the logarithms on a single side into one logarithm. What do I mean? I'm talking about our 4.3 rules for either expanding or condensing. So what does subtraction between two logarithms turn into? It turns into division. Now the other side is fine. You can leave a logarithm by itself on one side. Now, remember, if the log doesn't have a base, it's really base 10. So I would really need to take 10 raised to both sides to cancel out the log. One good thing that happens if there are logs on both sides is it cancels logs on both sides, so you're just left with what's on the inside. X plus 6 over x plus 2 equals x. Now to solve for x, I'm going to multiply the x plus 2 to the other side. So we get x plus 6 equals x times x plus 2, and I'm going to expand that by distributing the x. Now this is a quadratic. We see an x squared, so I need to move everything to one side. So I get 0 equals x squared plus x minus 6. Factor. That's x plus 3 and x minus 2. When I set those equal to 0, I get x equals negative 3 or x equals 2. Now you may think you're done there, but you need to plug them back in, because what can we never have in a logarithm? A negative number. Now look what happens when I plug negative 3 into the first log. Negative 3 plus 6 is positive 3, so it's fine. But negative 3 plus 2 is negative 1. Since we can't have a negative inside, that means negative 3 is thrown out. Now, let's do the same thing with 2. 2 plus 6 is 8, 2 plus 2 is 4, 2 is 2. This one's fine, which leaves us with just the one answer. And we'll do more after.